some of my Pittsburgh colleagues are coming in September to Berlin. So I'm really looking forward to this event and hope for more synergies, more cooperation, and a great exchange today. Thank you.
Thank you, David. Yes, I mean, the first event and also during our collaboration with both of the cities, we noticed that there are very strong ecosystems from both sides. And if I can ask all the participants to tune themselves. Thank you. Yeah, so, and we were very impressed by how ecosystem on both cities work very close together in very close partnership. And we thought that to continue the same philosophy in this webinar, that we start with very short overview about how the both ecosystem in robotics work in Berlin and Pittsburgh. So I would like to now invite Jens Wolke, Manager Innovation for Manufacturing Industries at Berlin Partners for Business and Technology, to tell us about what's so special in Berlin as far as robotics is concerned. Jens?
Yeah, I hope you can hear me now.
Yes.
See my presentation. Perfect. So yeah, thank you very much for having me, and a warm welcome to my introduction to the robotic ecosystem in Berlin. I'm from Berlin Partner. Berlin Partner is the business and development agency of Berlin, and we support the local ecosystem. So there's no robotic association as in Pittsburgh, but I think as Berlin Partner, we support all industries, and I think we're qualified to give an overview about the ecosystem in Berlin. Okay. Presentation doesn't go. No, sorry. Okay. Yeah, as Berlin Partner, we support the local industry, but also we support companies that settle down their business in Berlin. We do account management, technology support with technology transfer and innovation support. And BRE we also run marketing campaigns for Berlin. Before I go a bit deeper into the ecosystem of Berlin, I want to give you a short overview about robotics in Germany. So there are over 230,000 industrial robots working in German companies. That is around about 33% of all robots that are used in Europe. That makes us the fifth largest robot user worldwide. So robots are not from the technical side or from technology in Germany a big thing, but also from the user perspective. In 2019, Germany had over 550 patents related to robotics. That is around about 5% of the worldwide. The leading is China, then Japan, then South Korea, and fourth is the US. So I'm glad that we can change today to foster more projects related robots and to register more patents. Yeah, the Berlin is a vibrant research ecosystem with over 70 universities and non-university R&D institutions, with over 200 students, many startups, and many new startups coming every year. And also big companies have their incubators, accelerators, and digital units here. And not only if you are working on high technology and robotics. These are the main industries in Berlin, or the industries that are supported by the Senate of Berlin, and all of them are somehow involved in robotics as a user or as a provider, such as the photonics industry. They provide sensors, for example, for the robotic industry. So now I'm come to robotics in Berlin. So we have three main topics addressed by the local actors. One is industrial robotics and automation, the care industry, and we are very strong in software and machine learning. Overall, there are around about 60 robotic companies in Berlin, And companies, they're like real robotic companies, and this number excludes all sensor providers or companies that produce parts for robotic companies. There are 60 real robotic companies. To give you a short overview about how diverse this area or the robotics in Berlin is, I brought you like 5 examples. On the left up corner, there's Robotics. They developed a robot that paints walls. Below, it's a photo of the company Niemeyer. They automated soldering processes. The big photo in the middle is from the company AidMe, or is a startup. They developed a robot that cooks meals. For example, for companies that don't have a cafeteria, this is a very impressive solution. And on the right up corner is the company Mimic Productions, or photo from them. They patented a humanoid skin. And underneath is another startup called Continuum Innovation. They developed a highly flexible robot. So, in the beginning, I told you that Berlin doesn't have an association or a robot association, but there are 4 main organizations that are strong or involved in robotics. One is the Werner von Siemens Center, which focuses on industrial production or industrial manufacturing, and that includes robotics. Then we have the Motion Lab, which is a hardware lab that provides machinery for hardware prototyping. Then we have the Human VR Lab in Berlin, which is a lab that transdisciplinary combines different technologies like VR with robotics or artificial intelligence with robotics. And another big player is also an industrial robotic, is the Berlin Center for Digital Transformation. We have I told you already, we have a strong science, strong science and research actors in Berlin. These are all the actors active in robotics, and also here, robotics in Berlin is very diverse. In the right up corner, we have the Charité that focus on robotics in the operation room. But we also have, like next to it, the BHT that focus on humanoid robotics. We have like the TU or Fraunhofer that focus on industrial robotics. TU also on soft robotics. Then the HTV focusing on cobots. So very diverse, but there's a lot going on in Berlin. Education on robotics. Also here we have a bachelor degree on humanoid robotics and a master degree on Industry 4.0 with a big part in robotics, but also all other universities, they have some lectures in robotics. So this is my last slide. I want to give you, I want to end it with some news from the capital region in Berlin. So this is a cooperation between Domino's and a Berliner company called Teraki. They started delivering pizza with a robot. And another one, this is the cleaning agency of Berlin. They plan to use robots to clean parks. So I'm looking forward to supporting you in Berlin or to connect you with the Berliner ecosystem. So if you have any questions afterwards or the slides, we will provide you. But please don't hesitate to contact me. Thank you.
Thank you, Jens, very much for this introduction to ecosystem in Berlin. And now to have real conversation, we of course will invite Pittsburgh to make similar or maybe parallel presentation about the ecosystem in Pittsburgh. I read somewhere that Pittsburgh has a mission or aim to be the capital of robotics, global capital of the robotics. So Ryan, maybe you can explain us, can you tell us a bit more about this mission and how you want to achieve it? Ryan Oshie from Pittsburgh Robotic Network, please go ahead.
Great. Thank you for the introduction there. As was said, I am Ryan O'Shea. I'm the Communications and Engagement Manager for the Pittsburgh Robotics Network. We are a nonprofit organization that represents the interests of the robotics companies here in Pittsburgh, helping them commercialize their products, make connections around the country and around the world, and encourage companies that are outside of the Pittsburgh area to come here to see what's going on, to partner here and invest here and work here. There's so much to see about the Pittsburgh robotics ecosystem, and that's what I'll get into now. See if I can advance here. All right, so just a quick background about why Pittsburgh. So Pittsburgh has long been an industrial city, and it's long been a world-changing city. The first settlers from Europe came here in the mid to late 1700s because of the coal in the region. And that gave birth eventually to the steel industry, which is what Pittsburgh was known as, the steel capital of the world. That was an industry that was largely led by Andrew Carnegie, a Scottish immigrant that came to Pittsburgh and built one of the largest companies in the world here. And the steel that was made in Pittsburgh built buildings across America and around the world. And eventually that gave rise to other technology companies, such as Westinghouse, who was big with electronics and working on the railway industries. And in 1939, Westinghouse created Sparko. And that is the robot that you see on the right there. That's the dog. His owner is Electro. They were debuted at the World's Fair in 1939 as that's a 7-foot tall humanoid robot that can talk and sing and move. It was very advanced technology for the time. And that was advanced technology for decades to come, as Electro and Sparko toured the country and the world for decades as a sign of the work being done by Westinghouse and being done in Pittsburgh. And in 1979, Westinghouse partnered with Carnegie Mellon University to create the first robotics program in America. That went on in the 1980s to become the first degree-granting robotics PhD program in the world. So the birthplace of academic robotics really traces their roots here to Pittsburgh. And Carnegie Mellon University is still the #1 school for computer science in the world. And the Robotics Institute is within the School of Computer Science. So this is a world-leading institution that is creating the software, the AI, and the robotics that are building the industries of tomorrow. And it didn't take long until that really was put into effect. 1985 was the 3 Mile Island nuclear accident here in Pennsylvania, not far from Pittsburgh. And this is the birth of field robotics, when some of the students at Carnegie Mellon University used the robots that they were developing to clean up the waste and the accidents from this nuclear incident. So this was showing how robots can replace situations, keeping us safe and taking care of problems. That's something that's continuing till this day. And also, Pittsburgh is the birthplace of autonomous vehicles. What you see here is a vehicle known as Boss that won the DARPA Urban Challenge and really launched the commercial self-driving industry. But that's not the first self-driving vehicle in Pittsburgh. Self-driving in Pittsburgh traces its roots to the 1980s when there were minivans driving around Pittsburgh autonomously way back decades ago. But when we won this challenge, that really launched what became the commercial industry. Many of the students that worked on this team are now the leaders and the founders and the engineers of self-driving and other robotics companies from around the world. And Pittsburgh's no longer this great secret when it comes to robotics. This is what we are known for. We've grown from a steel city to a healthcare city, and now we are known as a robotics and AI city. And I think that's going to continue for quite a while. We have the infrastructure here. We have the foundations. We have the support from the work that's been done in the past, and that is driving industry forward today. We not only have the academic work that's happening at Carnegie Mellon University, the University of Pittsburgh, and other institutions in the area, but we have the commercialization. We are creating that pipeline from research and development to technology to the market. This is an example of some of the leaders in the robotic system here in Pittsburgh. I'll go into some of their companies. But some of the people you see on this are in the top right is Red Whitaker, who is from Carnegie Mellon University. Marshall Herbert is on the top left. He is one of the leaders of the CMU robotics program. We have Jorgen Pedersen on here as well. We have Brian Selesky from Argo AI, which I'll get into soon. These are the people that when you think of robotics, these are the world leaders in the industries, and they're based here in Pittsburgh. And there are many industries at play here. We are feeding the world with Fifth Season on the top left. Next to that, we're going to the moon, literally, with Astrobotic, which is seeking to be the first ever commercial lunar landing in history later this year. Many industries are represented here, and we'll get more into some of these companies individually. But this is a landscape chart that might give you an idea of the amount of companies that are here and the types of industries that they are in. So the top 3 boxes and the one in the bottom are companies. These are commercial entities that are working in the Pittsburgh area in robotics. On the bottom right is the companies and the organizations that are helping to build the ecosystem. You'll see the ARM Institute's logo there. You'll hear from shortly. On the left, state, that's the US government. There are companies and are feeding the talent from these institutions to these companies as well. This is a birthplace of the technology and of the talent that is putting it together. So feel free to check out this chart later. I can send it around. You can see all of the companies that are working in Pittsburgh. And I just want to be clear, this is specifically either companies that are building robots themselves, or in some cases, the software that runs robots. This does not include suppliers, sensors, component manufacturers, or in many cases, some of the integrators. So we could make this chart a lot larger. And of course, autonomous vehicles are something that Pittsburgh is now associated with. This is Argo AI, a company founded by Brian Selesky of the University of Pittsburgh, a world-leading self-driving company. And of course, they have a connection to Germany as well. Volkswagen has invested $2.6 billion into Argo AI in 2019. I believe this was $1 billion in money, and then 1.6 billion was the valuation of Volkswagen's autonomous vehicle sensor in with Argo AI's European headquarters. So this is some of the collaboration that we already see between Pittsburgh and German robotics companies. And of course, they are on the streets testing there as well, just as they are in the United States. So I'll very quickly go through this because I know I'm short on time here, but some of the industries that Pittsburgh Robotics are working in are the supply chain, checking out retail inventory, palletizing and depalletizing. We are working with the supply chain overall in terms of logistics, getting things to where they need to go. FedEx Ground is headquartered here in Pittsburgh and is very interested in the robotics companies that are here who are pioneering in this space. Again, some more of that supply chain work with IM Robotics. Astrobotic, again, is going to the moon. RE Squared Robotics was recently acquired in a $100 million deal by Sarcos. They make advanced robotic manipulators, so robotic arms, for many different applications. And Agility Robotics, which makes a bipedal walking humanoid robot for warehouse and delivery here in Pittsburgh. What used to be steel mills are now robotics manufacturing centers here in Pittsburgh. And Carta is mastering 3D imaging and digital twin technology, and they're really pioneering this. So there is a lot going on in Pittsburgh. I want this to be an invitation for you to come visit, see what's going on here. We have many robotics companies in densely packed areas, as you can see in this map, many of them in a very small 1 square mile area that people often call Robotics Row. This is all happening in Pittsburgh, and you should really come see it. We're happy to show you around. So thank you, and feel free to reach out with any questions.
Thank you very much. I'm sure there'll be a lot of discussion in the networking session and breakout rooms about the comparison and possibilities in Pittsburgh. And of course, it was in both ecosystems. Very important partners and stakeholders of development of robotic ecosystem are research institutes. And this time I would like to invite representatives who can tell us a bit how the development of robotics goes from perspective from research institute. Sorry. I'm sorry. And I'm sorry. I will give a floor to Matt Rosenberger from Advanced Robotics for Manufacturing. Sorry.
All righty, thank you. It's great to hear from Jens and Ryan earlier. My only regret is that I wasn't part of the initial meeting with Berlin back in January with AI, but very glad to be here now and to talk about what we're doing, Pittsburgh, and more on a national scope. So let me bring up my slides here. Okay, so to give a bit of a background about who the ARM Institute is, we are based in Pittsburgh, but what we're part of goes back a little bit further than in our inception in 2017. So we're part of an initiative that started in 2008, 2010, with a specific purpose to reshore and refortify US manufacturing. And so our government partners and the DoD, Department of Commerce, Department of Energy, started to deploy institutes across the US to address manufacturing challenges in specific sectors and focuses. And in 2017, our Department of Defense partners said, hey, we need a robotics institute. And so Carnegie Mellon University put out a proposal and won that proposal with the DoD. And so we were initially seeded with a $70 million investment from the Department of Defense. And our DoD partners basically tasked us to build a membership ecosystem, which we have done, a very diverse membership ecosystem consisting of 350 members nationwide, and to conduct project calls that are designed to address and squash the challenges that are standing in the way for adoption of robotics and automation in the manufacturing setting. So as I mentioned, we're headquartered in Pittsburgh at a place called Mill 19 in Hazelwood Green. I'm actually going to show you next a short video of our headquarters and kind of give you a feel what it's like in this transformation in Pittsburgh from what Ryan mentioned before, the Steel City, to now this new technological city that has a lot of backbone behind it. This video is about 2 minutes long here. Actually, the scale. Trying to share my audio here. Yep. Okay. Good.
Scale and the size of the mill is something you just don't appreciate unless you're standing under it. And it's been here for almost 100 years, and it'll be here for another 100 years because that's the way we build stuff in Pittsburgh. Hazelwood Green is an amazing site, but it was a steel mill and a coke works, so there were environmental issues. They all had to be dealt with and resolved before you could go vertical with development. Here was this 1,500-foot long rusting metal structure that kind of was an eyesore, but also an icon. And so we were confronted with the challenge of how do we preserve the icon and turn it into something really positive on site.
MSR Architects out of Minneapolis, St. Paul provided an option that we didn't even think about, putting the buildings within the building, keeping the exoskeleton, and using that as a solar shed.
The thought of putting solar panels across a quarter-mile long building, which is the largest sloped roof solar panel installation in the entire country, in and of itself presented a really tremendous opportunity for the foundation.
It is generating power for the 2 buildings that are already built and will provide power to the 3rd building as well.
All the stormwater from this site runs into a channel all along the length of the building. That water all flows into cisterns for gray water use.
One of our hallmarks is brownfield reclamation and redevelopment. Here in Hazelwood Green, Mill 19, we bring together the environmental remediation, the historic preservation, and the new cutting-edge companies and jobs.
If you stand out here in an afternoon, you'll see the bald eagles swirling above the site. The resilience and rebuilding of Mill 19, integrated with the community, housing the new technology of the future, is really emblematic of Pittsburgh.
Okay, so that gives you an idea of our headquarters. We definitely invite you to, if you're in Pittsburgh, not only take the tour of the robotics scene, but also visit our Mill 19 headquarters. We share that space with Carnegie Mellon University, a local manufacturing extension partner called Catalyst Connection. And also, I think you saw in the video, our neighbors is a company called Motional, which is a Hyundai-owned autonomous car company. So this particular site, there's a lot of development going on. There's commitments from University of Pittsburgh and the R.K. Mellon Foundation to put a BioForge Center, which would be a biomedical technology center. So again, expanding upon the industries, the healthcare industry, and also we're really trying to take the technology readiness levels from research to commercialization in one sort of setting in Pittsburgh. Okay, so as I mentioned, we're part of this initiative called Manufacturing USA. It's now 16 institutes across the US. All of them have different focuses and scopes. There is a flexible hybrid electronics manufacturing institute, additives, lightweight materials, advanced composites, the list goes on. Most recently, there was a biomedical institute launching in Texas, San Antonio, Texas. That'll be the next institute coming from the Manufacturing USA. So our mission as an institute is to accelerate the development and adoption of innovative robotics technologies that really are the foundation of every advanced manufacturing activity today, but also in the future, in the next 10, 15, 20 years. We do this by leveraging our very unique, robust ecosystem. And this is a partnership that really spans a triumvirate of industry, academia, and government. And we really believe that what we're able to accomplish with our project calls and with innovation isn't possible without bringing those three legs together. And ultimately, what we want to do is we want to make the robotics, autonomy, AI, all of these best practices more accessible to US manufacturers, large and small. We also want to make sure that the next generation workforce has the resources to be skilled, upskilled, reskilled, to be able to work in these robotic careers in the future. Definitely global competitiveness comes into play when we talk about securing supply chain and national security and resilience. Our vision as an institute is we want to lead the way to a future where people and robots work together. And very key there is that people and robots working together to respond to our nation's greatest challenges. And certainly to produce the world's most desired products and services. Our ecosystem, as I mentioned, is about 350 members, very diverse, wide representation. They are national. I'm sorry. Well, okay, so yeah, 350 members, very diverse ecosystem. We do have defense supply companies like Raytheon, Lockheed Martin. Siemens is one of our biggest partners when it comes to project calls. A lot of the robot companies, Yaskawa, Fanuc, ABB, and then a very robust ecosystem of startups, many of them in Pittsburgh. As Ryan mentioned, many of these startups are spun out of Carnegie Mellon University, and we like to be a resource and a guide for them in this journey to connect commercialization. We do have some of the top US universities and federal labs, community colleges and trade schools. And when we talk about doing the work in workforce innovation, these partnerships with community colleges, trade schools, and the top universities are very key. As I mentioned, we share our space at Mill 19 with a manufacturing extension partner, Catalyst Connection. MEPs, we call them MEPs in the US, there's pretty much one in every state. And we look to kind of expand our relationships with the MEPs so that we can get closer to industry in different pockets and regions throughout the United States, as we recognize that different regions have different needs and different workforce challenges. And then certainly we have industry association partnerships like A3. We just attended recently the Automate 22 conference last week, and certainly government partners as well. Our technology focus areas, and we do call out 5 of them when we talk about conducting our project calls: risk reduction and safety to transition to the factory floor, human robot interaction, interoperability, reconfigurable, agile, flexible robotic work cells, and AI and intelligent robotic systems. Those are our initial technology focus areas, although as time continues on and we are in our 5th year of operation, our priorities continue to change and we start to look more at AI and the intelligent systems and how they interact with the robots. We do conduct discovery workshops. We have working groups that we're launching this summer around some of the topics that we're talking about here, AI, human robot interaction, and more. And the idea is to continue the conversation of those topics and create innovation, and really to help guide our project road mapping when we talk about funding opportunities. What do we continue to fund, and what industries and what challenges are out there that we can help address? So as I mentioned, on the workforce side, we are doing a good bit of work. We've created a website called roboticscareer.org. We have also mapped out 26 competencies and job titles, including a robotic technician, an integrator, and a specialist. In that roboticscareer.org website, we've compiled over 14,000 programs nationally to help students find the right programs to get skilled in those different departments. We are adding different capabilities like job matching, where employers can pull from talent, as well as some AR, VR skill credentialing. So as we look ahead into the next 10, 15 years, and the last piece I'm going to show after this slide is just a quick video of one of our projects that we funded with Siemens and an autonomous drone swarm inspection. But when we look ahead in the next 10 years, what will the workforce look like, right? Robotics, automation, AI, it's going to be the biggest influential piece of the worker in the future. And we're looking to lead those conversations and the topics in the US. Also looking at what is the impacts of robots and machines in the manufacturing setting. Or how does that affect the worker? We continue to convene experts in, as I mentioned, the triumvirate: academia, government, and industry, to continue to shape and mold those answers. So last piece here, I'm going to show you a demo video of one of the projects that we funded. If your company is interested in making an entry into the United States, or if you're already here, we would love to talk to you and see if we can be a resource for you in your journey for automation and robotics, as well as to connect you to our ecosystem of government and industry partners. All right, let me show that video real quick. And this one is about 2 minutes as well.
Initially, we were looking at power plant inspections, long.
Not getting any audio there. All right, I'm gonna have to skip that video because of lack of audio.
Matt, we were getting the audio.
Yeah, we hear you. Yeah, it was good with audio. Matt? Okay, maybe you can share it if you send Matt the video to me. We could hear the audio. Maybe you wanna try again, Matt? Can you hear us?
I'm sorry. Okay, yeah, go ahead.
Yeah, so we could hear the audio from the film.
Oh, you could? Okay,
Yeah,
great.
yeah.
Let me
So
put
you
that
can
on.
try again. Yeah.
Okay.
Alternatively, you can also share it with me later. But yeah, I think it's good to see it.
Perfect. Yeah, no, this will be a good demonstration of the type of projects that we're working with.
Initially, we were looking at power plant inspections, long lines of piping and valves to where the drone can fly in, take immediate pictures and images, find if there's any leaks, and you don't want to get personnel into that area due to safety.
The inspection would be autonomous. We put it in a shoebox, let's say, right? And we can fly outside of the shoebox. In an initial phase, we would assess what is this object inside the shoebox flying far away from the boundaries of the box. In a second stage, however, we need to get close. If we want to get high resolution imagery, we have to get really close.
Utilizing our modeling, simulation, and design software, we're able then to do a full check of the ship factory plant operation.
ARM is focused specifically in robotics technology for manufacturing. So we're trying to make these processes more efficient and safer, as well as make sure that the DoD sustainment community is available in order to keep our country safe.
Working with ARM allows us to access startups and industry partners and academia. We're very excited about having this relationship. It's something that we've been part of for over 5 years, allowing us to do really impactful research, both for the industry and also for the Department of Defense.
We're also looking at the industrial manufacturing capabilities that those technologies can produce, an advancement for the United States economy in the area of robotics and artificial intelligence.
My father served on the USS New Jersey in the Korean War. It's very interesting that I'm part of this particular project, giving back to our country in that capacity. The New Jersey still serves a role in our government in developing technology and serving our country.
All right. Yep. Thank you guys for watching that video, and thank you for letting me present today.
Thank you very much for your interesting presentation. And I would invite now Olivier Heimann from Fraunhofer Institute for Production Systems and Design Technology. Olivier, if you can tell us a bit more about the landscape of Research Institute here in Berlin and how is it supporting the development of robotics?
Yeah, absolutely. Thank you very much for the introduction. So as has already been said, my name is Olivier Heimann, and I'm the Deputy Head of the Department for Process Automation and Robotics here at the Fraunhofer IPK in Berlin. So I guess I'm not sharing my presentation right now, am I? Second. All right, so the Fraunhofer Institute for Production Technology is located in the center of Berlin, and we are deeply intertwined with the University of Berlin as well. And you see the building on the screen now. So everything is kind of circular shaped, and we'll get back to that later on, since it's sort of important for our ethics of work, I guess. So who is Fraunhofer? We are Germany's largest research organization, even Europe's largest research organization. We've got about 30,000 employees at 76 different locations all over Germany. And as you can see right now, we've even got offices all over the world. And the closest one is actually quite close to Pittsburgh. It's in East Lansing in Plymouth, which is about a 5 hours drive to Pittsburgh, as Google just told me. But they're not focused on robotics yet, but we are close by already. So we get in touch, I guess. We are mostly focused on engineering and engineering science and other STEM related topics. So biology and math, as well as about 15 different institutes that just focus on production and assembly robotics. And then we've got, yeah, going from here. It's quite a bit slow. my screen still sharing?
Yes, but we still see, oh yeah, now it's the second next slide. Yeah.
So this is the inside of our test bed or building. So everything is circular shaped, as I initially said, and it's the grounding or the founding spirit of the founder of the institute, that everybody could get into the laboratory real fast. So all our office buildings are all around the test bed. So everybody just has a 2-minute walk to their machines, to their robots and everything else. And we can simulate an entire factory within our test bed. So we get to explore the different integration of robots and machines and machine tools and everything else, as well as research on company management systems and product development. So we've got an entire department just focusing on building products that are easier to manufacture or that are more carbon neutral, and research on different aspects of product development as well. And then we've got machining and machine tools, which was one of the original ideas of the institute. So we've got quite a lot of machining machines and focusing on grinding technologies. And in the last 10 years, we've also started to employ robots for grinding as well, since there's quite a few benefits in using large-scale machines, which are quite cheap to buy. For example, if you think about grinding and milling on wind turbines or other large machinery. And then there's process automation, which is where our robotics department is placed within. So where did we start from? So the very early robotics research at our institute was robot control systems. So one of the earlier robot control systems for Siemens was actually developed together with my colleagues. Obviously, I'm a little bit too young to have been around at that time, but it started here, and we've been building on that legacy for the last 30 years. So we went quite strongly into force torque control and human robot interaction even in the early 2000s, and we've built some of the first cobots that helped pick up large weights while still interacting with humans. So we started early in enabling easy assembly processes for large-scale manufacturing. And then with the internet coming up, we started in automation as a service and other digitalization of the factory environment, Industry 4.0, which has been a strong topic for the last 10 years for our institute, where we focused on software development and flexible software solutions and integration of sensors as well. And now we are focusing more and more on flexible robotics, which is the idea of dealing with uncertainty. So as we start to see robots get employed in more and more different areas, everybody has to deal with uncertainty in the modeling, uncertainty and sensor noise, as well as just dealing with new and novel environments. So we can no longer build rigid robots or just rigid robots, as they just not meet the requirements of the industry, and they do not meet the requirements of different domains. If we think about agricultural robotics or anything else, there's no such thing as a rigid field. So everything is different and everything requires sensors and cognitive and intelligent robots, which is what we're working on and focusing on now. And you'll see in the upcoming presentations of our different research topics that it's all focused about on dealing with this uncertainty and trying to build around the uncertainty in our world. So one of our research topics is our autonomous mobile robots and flexible interlogistics. So we are building robots that are capable of interacting with machine tools and planning for an environment where humans are also integrated. So we have to deal with algorithmic and sensoric information on the fly. So we integrate modern communication standards to use large-scale computational environments and servers somewhere else in the cloud, while still allowing the robot to fluidly interact with machines. And we can see on the right in the video, we've also got fully integrated digital simulation of all of our robots. And in this case, we are using ROS to not only simulate and visualize the virtual robot, but also to use planning algorithms for our real robotic systems, which help us build prototypic applications really fast. And then we've got a human-centered automation, which again is trying to deal with an environment where the human is dictating where to go, what's going to happen. Only the human knows about the plan. So the robotic system has to see and interact what's going on. And in this case, we're using cameras and different machine vision algorithms to not only detect the human's interaction and the human's gestures, but also the workpiece itself. And then we employ knowledge about the process. In this case, we are simulating a welding process to detect the objects, intermingle it with the human's intention, and automatically generate a program for the robot. And all that combined with an intuitive to use interface. In this case, we've been working on augmented reality. And then we've got flexible fixtures and grippers, which is sort of the old school solution for dealing with uncertainty, but it's helping quite a lot since they are always faster and more reliant than sensoric and algorithmic solutions. And as we can see in these two videos, it allows us to deal with uncertainty of up to a few millimeters in position without breaking anything and without slowing down the process to an unbearable step motion that sometimes happens when you deal with novel algorithms. And this has helped us in different applications in some recent industrial projects as well to solve pick and hold processes as well as assembly processes such as screwing and screw driving. And then we've got soft robotics, where we focus on active and passive interaction and support for human workers. So in this case, we are seeing an actuated jacket, which is supporting the worker and which is keeping some, giving him some extra additional strength through pneumatic devices. It's not visible in the video, but it's audible if I would turn on the sound, that every time he's moving his arm, he's getting some extra boost from the pneumatic system. And we're employing sensors and algorithms to not only detect the motion, but also reason about the intention of the user to only support him when he's actually needing the support and not block him or work against the user. And using the same pneumatic technology and the same soft materials, we're also building different grippers for food handling, for example. So if we think about handling tomatoes or cucumbers, they're easily damaged by state-of-the-art grippers, which is another topic when we think about using robots for more different domains and breaking the barriers of rigid assembly lines. And lastly, we've got different aspects of human collaboration. This is building on our earlier works from the 2000s. So we are using robots and force torque sensing as well as intention recognition, which we can see in the video in the middle, to help or to enable applications where the human is guiding the robot, even robots that are not built for human collaboration, robots that are way too strong, way too big for classic human collaboration robots. So as we can see on the right, the robot's capable of lifting heavy goods. And while the video is better ×2, you can still see that the worker is still required to do some heavy work, which is due to limitations in the control theory, but still he's able to lift up a heavy piece without too much effort. So what's our offer? We are a reliable partner for all your research endeavors when it comes to machining, assembly, and robotics applications, and we can help all of your companies with applications for public research funding. We can also help with building consortium formation for private or even for public funding. And we also have experience in doing that nationally and internationally. So especially EU funding has been a long ongoing business for us. We also offer project management for research projects. And obviously we also offer private contracted research where we could offer you automation potential analysis, where we apply all our research knowledge and help you figure out new ways to assemble your goods. But we also do feasibility studies for different aspects, for different ideas. We build prototypic applications, and we develop algorithms and software and test them in prototypic environments. So we're not a company we're looking to selling those algorithms directly, but we are building those prototypes. And we also offer workshops and trainings on robotics and AI if you're interested. So thank you very much for your attention, and I'm looking forward to the breakout sessions later on.
Thank you very much. Of course, now after good contribution for also research perspective, the overview wouldn't be complete if we wouldn't invite companies who are inventing different solutions. So we'll have now a short pitches from the companies from both cities. I would invite first Matthias Krinke from Robotics from Berlin to share some insights about your company.
Yes, thank you very much. Piper Robotics already exists 28 years, and we are specialized in robotics and machine vision applications. We are located exactly here in Berlin, and I'm also sitting here in this building. And we have 4 fields where we are offering applications specialized for the needs of this market. So this is factory automation, supermarket, which is robotics for retail, solar, which is quality inspection for solar cells and photovoltaic modules, and robotic application for life science. I will show you some applications now in this 5 minutes we are doing, but first I will invite you at the entrance of Piper Robotics, where you can see one of our newest products. We just presented last year our Concierge Robot, who will take care of you if you come and visit us. And this robot is also possible that you can rent it via our partner company Robocene with a monthly salary. So this robot is able to talk to you, to understand you to a certain extent, to recognize you, to compare your face with your passport. The robot knows when you have an appointment with me and shows you the way to the waiting room. So this is one of our newest products. What you see here is all what we do. We do the engineering, we do the production, and we sell and develop also components. Let's have a look at the engineering department. These are the components and the development tool we're using. And what you see here is also that we developed our own cloud, which gives our machines the possibility to get automatic upgrades on air and to inform us about the necessity for spare parts. And if our customers allows it, then the machines automatically can purchase in our cloud the spare parts, and we will deliver it directly to the customers. For sure, also we have, especially in our machine vision applications, artificial intelligence. Since already 20 years, we're using neural networks, and now we have the possibility to connect all of our service robots with our cloud, where we have the neural networks running. And the good thing is that the robotic community then is just able to use the knowledge of the whole Piper Robotics community. So let us look in the production and some applications we offer for factory automation. We just specialize here for electronic manufacturing, and at the beginning we are offering engineering support for the logistic part, especially also for mobile robotics. And if we go into electronic packaging, for example, we have developed assembly stations based on our WorkerBot 3. WorkerBot is the name for factory working robots we developed for special applications. So if you look here, you see a mobile WorkerBot 6, which is able to drive from one workplace to another, or a dual arm WorkerBot here inside the stations doing a sorting application or assembly applications. So this one is not mobile because it's 250 kilograms, but it's flexible in that way that you can move it with a forklift to different places and use it there. The whole electronic machine vision and everything you need is integrated in this platform. And there are just different applications, like here, ultrasonic welding application in this image. And then if we look here at the PCB assembly, you have an THD line where we have feeding robots. These robots are feeding THD electronic parts and placing them on the circuit board. Here we have a laser system for laser marking, and this is a robot doing in-circuit testing. So the robot is loading and unloading in circuit testers. It's a very open environment, so you can manually load and unload it, or you can bring the magazines here with a mobile robot to the system. So it's fenceless, but with optical safety fences. Let's have a look at the microfactory. I really like this concept because we have these cubes. You can easily transport them even by car because they have integrated lifters, and you put them on your car and combine them to groups where you have the logistics done by mobile robots, or you put them very close together so that they have a direct transport from the parts from one cube to another. You will see a few slides later also a totally different application of that in the field robotics for retail. And here, this is again our robo feeders, how we call it. So they do bulk feeding, a packaging station, and a mobile robot picking up the parts, bringing it to a workplace where we have also human-machine collaboration. We have their camera system based on artificial intelligence, looking at that, what the human is doing, knowing what the robot is planning to do, and giving the human then some maybe signals in a way. It's like talking to the human, please take your hand away, or just waiting until the human finished the work. And this is just your machine tanning application, also very flexible with integrated force feedback in the robot. So the good thing about this application compared to others on the market is that you can just move it to the machine, and the machine with this integrated force feedback is checking for the position in relation to the machining system, and is therefore very easy to use from workers who have no robotics knowledge. So you don't have to be a robotics specialist. You just move it there, press the start button, and the robot is taking care of the positioning and starts work. So just another point of view here on the collaborative work. This is also part of a research project at the moment, which we finish in the next 2 months, and then we can offer it to the market. So this is just like a conventional fully automatic line where we have automatic assembly, isolation tests, laser marking with a robot, and also a smaller assembly station based on our dual arm worker bot platform. As I mentioned before, we have everything integrated in here. And here, a configuration of 3 industrial robots where we also do assembly work. So that's like classical factory automation with different styles of robotics. And well, at the shipping part, we have then also a palletizing robot, which is, for example, also used at the German Bundesbank or minting companies all over the world. And let's have a look at a photovoltaic factory. Here we are since more than 50 years in the field of quality inspection. And we do that for the cells, but also for the modules, pre-lamination and post-lamination. This is basically also a robot looking with a sensitive camera and electroluminescence spectrum, and we can detect there all kinds of defects and have there a full automatic system. The new version is also based on artificial intelligence if the customer allows us to connect it with our own cloud. So these systems are all over the planet, working from China to Canada to United States. We have installed the systems. And it's still, I mean, as you know from the situation now, it's a growing market also in Europe, and we have more and more factories now in this area also in Germany. Let's have a look at the robotics for retail. We have here something which is called Workerbot Kiosk. You maybe remember, it looks like the microfactory I showed you before. but in this case, it's a small store where we can buy different products. Actually, since 2018, we are running one here in Berlin, and it's the smallest robotic company of the planet because the dual arm robot is building little toy robots in 4 minutes.
Mr. Krinke, your microphone.
Now you hear me okay? Again? Yes, thank you.
Yeah, yes, we hear well. No.
Yeah, okay. So this is the smallest robotic factory here on the planet. You buy 12 euros and in 4 minutes, the dual arm robot, which is a worker bot for sure, is building little toy robots for you. And as you see here, we have a lot of new products for the robotics in retail. It's like also WorkerBot 6, who's taking care of the customers and serving coffee and other stuff. We have marketing robots, and you can also have a larger storage for this little shop and behind with a picking robot. You can do also a pickup shop so that you can combine internet marketing and internet sale, shop sale, with this shop where you can just go there and pick up the stuff you bought in the internet. Oh, I'm sorry, but just some more views of this here. Like a mobile robot, that at the moment that was a prototype, at the moment looks different. So you will see the new version in 6 months from us when we bring it to the market. This is our marketing robots. And again, the WorkerBot kiosk, like a little shop. And finally, we have a look at here a full automatic laboratory. We are producing this also for the identification of cancer and ALS diagnosis. Actually, at Penn State University, they're using also one of the systems in their laboratories. And it's also a patented system, especially for ALS diagnosis. Well, our research partners, they think it's very good tool to have the possibility to detect ALS as early as possible, which is in this kind of disease very important that you find it or recognizes at the beginning, early beginning of this disease. We won a lot of prizes. The last was that we were Innovator of the Year 2021. And what you see here is also a robot from us. It's a DJ robot. And you can see this DJ, the robot is working on TUI Cruises shift since 2018. And finally, I just want to show you a very short video of the robot. I realized that the sound is not working, but I think it's not so important because I just show you the video. We have here 2 6-axis arms. We have the possibility to move the head. We have in the head a camera system to detect the people. We have a possibility that the computer interprets the music and the robot moves according to the music. So far from my side, thank you very much for your attention, and I'm looking forward to hear some questions from your side.
Thank you very much, Matthias. Are there any direct questions to Matthias? Let me check. Otherwise, there'll be opportunity also to talk to you during a breakout session in the room. I saw also there was another question before your presentation to Olivier Heimann. If maybe we can answer very shortly this question. If there are any successful international collaboration from Fraunhofer, Olivier, if you can just answer to this question.
There are quite a few. So obviously there's a European Union funding. So within the EU, we've got quite a few different international experiences and projects, and keep on winning new projects as well. going abroad, it's a bit different, a bit difficult as well, since it's harder to find public funding. So those are mostly privately funded contracts. So we've got projects within almost all countries all over the world, but they are mostly funded privately. So seeing that the question came from Matt, I guess, it's going to be a bit tougher for us to find private funding for that. But we've got a good example in Brazil, where we've got a project office where we're using different models, where there's a German company and us as a German research institute, and Brazilian research institutes and Brazilian companies. And then there's dedicated public funding for those sort of businesses as well. But it's a bit difficult and a longer story to figure out the details. So maybe we can discuss that in the breakout sessions.
Yes, let's hope this webinar will be maybe the beginning of such a partnership in the future. It will be a really great start. let's hope for that. I would invite now we'll hear a pitch from Pittsburgh side. I would invite John McElligott. John, are you with us?
I am. Great.
Yes,
thank you very much. Can you hear me okay?
Yes, very good. Thank you.
All right, fantastic. So I will come at this from a little bit of a different perspective, mainly because my company is not in Pittsburgh. We are very close to Pittsburgh, but I've spent a lot of time traveling back and forth. I'm actually going there tonight. So probably my experience may be very pertinent to some of the decisions that some of the stakeholders and companies and partners in Berlin may be thinking about their involvement in Pittsburgh. So instead of talking mostly about my company, I'll talk more about kind of my experience and how I stumbled into Pittsburgh and how welcoming they've been. So my name is John McElligott. I'm the CEO of York Exponential. So we began life as a collaborative robotics company right here in York, Pennsylvania. So in the United States, most people know York, Pennsylvania from the peppermint patty, which is a very famous candy here, but we're also the first capital of the United States. We're an industrial powerhouse through all industrial revolutions except the third, and we're very instrumental in World War II. I started my company kind of in response to a need that I saw in my community. I'm not actually from York, Pennsylvania. I'm originally from Springfield, Massachusetts, but when I was 8, my family decided to actually become missionaries and travel the world. So I spent a lot of time growing up in the United Kingdom, so England and Ireland and Scotland. When I came back to the United States, I somehow found myself in York, Pennsylvania. And one of the things that I noticed was that our town was an incredible powerhouse in the first industrial revolution. And in the second industrial revolution, when some of those entrepreneurs that started those businesses got older and wiser, they grew their businesses to be massive. But something strange happened, and this I've seen across all of the United States in these small towns, is when the businesses got handed over to the children, we went from being risk takers to caretakers. And for some reason, that mentality became very pervasive in the town that I lived in, New York, PA. And so when I first moved here, there was not a lot of industry left. All the storefronts were empty in our city. And I made the commitment that if I was going to stay in this town, that I wanted to contribute, because I'd never really felt like I was a part of a community. And I was convinced that it was technology, that we'd missed technology, and that we were going to have to begin investing and training people in this technology if we were going to be even relevant or have a chance to compete in the future. So I started my first technology company. And I knew nothing about technology, and all I knew was kind of from the internet. And I went to a couple of founders meetings and read the Lean Startup, and became a little enamored with Silicon Valley. Spent some time in Silicon Valley and Silicon Alley up in New York. But I started to realize very quickly that our town is a very small town, 52,000 people, old manufacturing town. We're very touch, see, feel, and software was just like magic. Like it didn't make sense to a lot of our community. I couldn't find the developers I needed. I raised some money, but not enough to really scale. And so one of the hardest things I ever had to do was close that company down. But I was undeterred, and I still believe that technology was going to be the key for small communities just like York. So I did more research, and I found that while a lot of manufacturing had left other communities, manufacturing was still very robust in York, Pennsylvania. We employed 40% more people in advanced manufacturing than the rest of the state, very strong defense supply chain. So we still had a lot of these old companies. So I'd never set foot in a factory. And so I started going on factory tours, and I just fell in love with manufacturing. To see what humans and machines together could create. Like, I didn't know how we got this or all the things that we have. You know, I came from move fast and break stuff. And so in my head, I was in awe of what humans and machines together could do. But as I started to walk through a lot of these different facilities, I started to see the same thing: an aging workforce and empty machines. Like, kids were not getting involved in manufacturing in the United States. We had a lot of these big machines, but that workforce was aging out. And so I became terrified that we were going to miss out on this. The same way we missed out on the internet, we missed out on mobile technology. There was going to be a new wave of technology that we were going to miss out on as well. So I really didn't know a ton about manufacturing technology. And so I did more research. And luckily for me, Pittsburgh is not that far from my house. So it's just a couple hours from my house. So I got in my car and I scammed my way into Carnegie Mellon and the National Robotics and Engineering Center, managed to meet with some professors and researchers. And they showed me some of what they've been working on. And this was over a decade ago. And my mind was blown. I mean, I could see that, it was at the very, very beginning, but things that they've been trying to do for the last 30 years were starting to happen. So all of them gave me the advice that it's almost here and it's not here yet, but it's going to be very close. So I came back to my town and I started a real estate development company, kind of biding my time for when this was going to happen in robotics. It hit a point where I could start to see the technology beginning to tip again. I left my last company and I spent 2 years traveling the United States, going to all of these small little communities, just like York, to figure out if you were struggling with the same problem the rest of the United States was struggling with. And it became very clear that right now we have haves and have-nots, but nobody was paying attention to artificial intelligence, robotics, and I was convinced there was a potential of us having haves and have-nevers. Like these communities and people would be left behind at a rate that there would be no catching up. So it kind of put me into overdrive, and I gathered as much information as I could. I came back to York, Pennsylvania. I exited my non-compete, and very quickly within our town, I raised about $4 million to begin scaling my company, York Exponential, very fast. But I also realized that there was going to be a big gap in workforce. And while Pittsburgh was focused heavy on the PhDs and the master's degrees, I was convinced we were going to need more people that were good with their hands, robot mechanics. So we were one of the first schools to become licensed to do accelerated education in AI and robotics, all combined with traditional manufacturing skills with the goal of creating the first generation of robot mechanics, so robot technicians. And this was about 6 years ago. Fast forward a couple of years and, still feeling a little isolated. But luckily for me, one of my advisors was the head of the Robot Soldier program, and he let me know about what was happening with the ARM Institute. So the Advanced Robotics for Manufacturing Institute in Pittsburgh spun out of Carnegie Mellon and the National Robotics and Engineering Center. And that was actually the reason that I came back to Pittsburgh. There was an ecosystem that was starting to grow, the Pittsburgh Robotics Network. There were other folks that were all starting to mobilize. It was starting to become very, very serious. And so that was my first step back to Pittsburgh. And that was several years ago. We were actually one of the first members of the ARM Institute. And it was mind-boggling to see how fast the technology had even come from that point. Now, for my traveling the United States and the work that I was doing in York, one of the things that I realized was we needed to shorten that timeline of where new technology was coming out and regular people and consumers were made aware of it. So they understood not only how to benefit from it, but how to do it responsibly. Like a lot of what Silicon Valley had done had happened in a vacuum. And one of the things that I noticed in Pittsburgh, it was not the same. It was a very different culture where it was more welcoming. It was a culture of makers and doers. And so the Advanced Robotics for Manufacturing Institute was kind of what brought us back. But very quickly, we started to build strategic partnerships. We spun off a couple separate AI companies through partnerships with ARM members. So these were outside of project calls. So the project calls were one thing, but just the events and the community that ARM and the Pittsburgh Robotics Network was forming has allowed us to do things and bring technology to places like York or Greenwood, South Carolina, or South Dakota, Yankton, these very small communities. And so one of the reasons that I spend so much time in Pittsburgh with the Pittsburgh Robotics Network, ARM, and the other organizations out there, and I would encourage all of you to do the same, is that the technology that's shaping the world is being created in Pittsburgh. And it's being created by entrepreneurs and organizations that actually do have community and manufacturing at its center. So there's an opportunity to begin working with an ecosystem that I believe actually beyond a tech ecosystem, a mech ecosystem, where we'll have PhDs all the way to robot mechanics, to manufacturers, to regular people, to people that are writing research papers. But we've got to find a way to shorten that timeline. And so that's been why I've been so excited about Pittsburgh and so motivated to not only be building those bridges, but bringing my mayor and having people from Pittsburgh and the Advanced Robotics for Manufacturing Network and PRM coming to my community. So I would leave you all with this. I would encourage you to get involved with Pittsburgh and to build this relationship, mainly because this is the first truly inclusive technology ecosystem I've seen. Like, I don't know if it's because it's mechanical engineers primarily, or you have to do things and it's just a very different mindset. But Pittsburgh has become a second home for me. And I hope that it becomes a second home for all of you. You'll find, I believe, a welcome there, the ability to work across lines and across the ocean. I think everybody there also understands the responsibility that they have to get this right. And so I appreciate the opportunity to advocate not just for Pittsburgh, but to hopefully welcome you all to the United States and Pennsylvania in general. if you come to Pittsburgh and you want to see some small towns, let me know, and I will be more than happy to make myself available. But Matt, thank you for inviting me today, and all of you, thank you for having me and allowing me myself just to promote Pittsburgh a little bit and get to know a little bit more about all the amazing things that you are all doing in Berlin. Thank you for the opportunity.
Thank you very much for your inspiring contribution. I hope you can stay for a breakout room networking session. Then people will have a chance to ask you a bit more question in smaller group. And now I will invite Professor Janse Lambrecht from Gestalt Robotic so that we can learn more about Berlin example of that company. Yeah, you can see presentation already.
And I need to unmute myself. So
yes, now we can hear.
Thank you very much for having me here and for the introduction. And so this nice international meeting that we are having here. So my name is Janse Lambrecht. I'm working in robotics now since more than 15 years and started with automation with a mechanical engineering background. And we founded the company Gestalt Robotics 5 years ago with a software focus, because we saw that a lot of value in automation is coming from software. And in this brief presentation, I'm going to present one of our current projects. It's called eCheck, and it's about automatic maintenance and inspection of the high-speed trains here in Germany. But before I jump into the project, just let me introduce our company very briefly here, founded in 2016. We started developing software as 3 founders, and now grew the team to more than 50 employees we have here in offices in Berlin-Kreuzberg, and still working mainly project-based, developing specific individual automation solutions to our customers. And our value add that we bring here is typically the software part, working with off-the-shelf hardware. We are fully independent and self-financed, and from the Berlin ecosystem on robotics, you may have heard the Werner von Siemens Center here before. We are one of the funding members of the Werner von Siemens Center, and just recently built up a testbed there, a 5G testbed for indoor and outdoor robotics. So that's a great opportunity also over there to work together with our partners. And one could also say that we are an alumni of the Fraunhofer IPK, more or less. So when we started in 2016, we were located for half a year at the institute there with support from the professor. So that was a big help at this time. So, but what are we basically doing? I already told you we are working on solutions, and our value add is mainly software. So we are based on a technology portfolio that is mostly control and computer vision functions. And we are based on the specific demands of our customers. We are then putting those functions together, building also typically distributed automation solutions, so involving cloud and edge. We have been involved in one of the first campus networks in projects in 2018 here in Germany with Deutsche Telekom. And so we also had a background in classic computer vision in automation technology. And we knew all the struggles and issues that we had in the past. And we saw this potential, especially of deep learning here, quite early in the beginning. And we're dealing with making deep learning industry grade since 2016 with a lot of experience with a lot of tech and tools there, and especially one technology, a few shot learning technology that also enables industrial customers to work with machine learning and the resulting good performance without needs for massive data sets, for example. So we're providing solutions in 4 different fields. So there's AI empowered computer vision, for example, for inspection systems. During the last years, we have entered the pharma domain with those kind of solutions. In 2018, we started developing our own software stack for autonomous navigation, indoor and outdoor, highly modular, could be distributed to cloud and edge, even the real-time functions from the autonomous navigation stack. So we've been working on this for quite a long time and have a lot of IP there. And then there is also the domain intelligent robotics, typically working here with distributed software systems and involving advanced sensing, and the same for worker assistance. So it does not mean that here a robot need to be in place in every project, but could also be that we are based on camera information, understanding environments. We are providing informational support for workers. And the project that I'm now going to present is somehow at the intersection of AI-powered computer vision, autonomous mobility, so mobile robots are involved, and also intelligent robotics. So we are talking here also about mobile manipulation and also worker assistance. So it's at the intersection of more or less all topics. But let me start with a short video of the preliminary project that was a proof of concept that we finished in 2020, so actually end of 2020 during the pandemic. And within this POC, we showed that with the help of a specific mobile robotic hardware that was developed here by a company from Britain. So our part was the software and all vision in this case. And we proved that you can reliably do inspection tasks. So in this case, under the train with this special robot, and you can do it on a human-like level, or even better. And this was a great success, this POC project, and was implemented in quite a quick time. I think it was a 2 months project, and then there was a bigger tender for this project called eCheck, which is dealing with automatic inspection and maintenance at 5 different locations in Germany. So the big issue in Germany is the train traffic should duplicate during the next years, but what could not duplicate are the inspection facilities for the trains and the personnel that Deutsche Bahn here in Germany has. So there's a massive need for automation and for support here in train inspection. And even when you had the opportunity to go with this nice high-speed trains here in Germany, you know that they are typically delayed, and maybe that's also one issue we can solve with this project. So we actually won this tender together with a company called Göttingen, building autonomous mobile robots. So they are building the hardware for mobile robots, and the Strama MPS, which is actually one of the biggest special purpose mechanical engineering companies here in Germany. So we are responsible for all the software part and the sensor systems. We have Strama with the general mechanical engineering, and Göttingen with specific AGVs or AMRs. So what are we building in this project? So first of all, you see these camera gates. The camera gates are in front of the inspection facilities. So while moving into these facilities, there are, I think it's 32 cameras on this gate, even one in the ground. So scanning the train while the train is going through for damages, so known errors or known failures at the surfaces, at the components, and also scanning here for anomalies. And so 32 cameras, this is a lot of data that we are collecting there with a hybrid approach. Part of the data is processed locally, at the specific plants, but also public clouds are used here. We are building this distributed automation systems, also gathering data from different locations from Germany, providing one unified pipeline for the machine learning. That is the basis here for the inspection. And then the result is that so you would have the inspection results when the train then finally enters the inspection facilities, and then the workers just get a tablet app and get a virtual model of the train, and at the virtual model there's marked where our system found these kind of errors. So this is also support for the workers. They could go more directly to the parts of the train where issues have been detected and have not to work the full distance of the train and look for everything. So there are also parts of the train where the camera gate could not really look into. So for this purpose, there are mobile robots also going next to the trains equipped with cameras. So arms here, for example, that can go under the trains with their flexibility in the movement and guiding the cameras. And the last addition is the maintenance. So what is also done in this project is releasing and and the input of the water supply of this trains. With these specifically for this project designed AMRs with two FANUC arms on it, and everything is quite flexibly. So one robot has a camera. The camera helps the robot to find the hatch here. One is holding the hatch, and the other one is responsible for releasing the water and then for the new water input here. So that's quite challenging. We are currently in the implementation phase already. The camera gates are currently installed on different locations, and we are already working on the mobile robotics applications from this eCheck project. So that was a little introduction of our eCheck project. I close with also some remarks of our customers and partners. So we are mainly working for logistics and production, but also having partners in the mobility domain, for example, where we provide assistance systems, for example, for the new subways here in Berlin. And we have a strong network here in Germany and in Europe with integration partners, but also with research partners. And one of the research partners, of course, is the Fraunhofer ITK here. So thank you very much for this little introduction of our eCheck use case. And of course, I'm also looking forward for the further discussions here. Thank you very much.
Thank you very much. There will be an opportunity to speak with Professor Janse later in the breakout session. And now, last but not least, I will invite Dipan Pal from Voyage, from Pittsburgh perspective. We have another company. Dipan, are you here?
Yes, thank you so much for having me here today. And thank you to Matt for actually inviting us to share our stuff, what we're trying to do. So I'll just quickly share my screen on my other machine. And if you guys can see the slides, let me know.
Yeah, yes, I'm seeing, presentation is here.
Wonderful, awesome. So thank you again for the opportunity to talk about what we're trying to do here. And I must mention that we are a small team out of Carnegie Mellon University. And we are a team of 3, but we have a large part-time and intern team driving a lot of the R&D for us. And we are a slightly different kind of company where we don't really focus on making hardware, but we make robotic operating AI that sort of results in an integrated solution or integrated system. So I'll clarify all of this, and then I'm happy to chat more past this. So what we find is that over the years, there has been amazing development in robotics. I mean, my background is not in robotics. I finished my PhD in neuroscience applied to deep learning at Carnegie Mellon, but it was just absolutely fascinating to see how robotics has changed and evolved from time to time. However, there's still, if you looked at the future, what challenges remain, as a lot of these other companies were amazingly talking about, there's this difficulty in handling variation in workflow, which is what task you want to do and where do you want to do it. And also objects, like what object you want to manipulate while doing that task. Second, you can't really move these work cells around on the fly while handling complex objects. And finally, you cannot reprogram these things on the fly as well. Why is this a need? Because 90% of US manufacturing, at least, are SMBs, small to mid-sized companies. And even some of the large companies have smaller locations. You need robotic work cells, which are sort of compact as well, which have flexibility in being applied to different tasks. So what we're trying to do at Voyage is building vision-based, reprogrammable operating AI software. And so why are we trying to do this? We're trying to do this to handle workflow and object variation while being movable and relocatable. Now, I understand that workflow variation is a huge, it's a huge can of worms, but we are starting with simpler tasks like pick and paste, sure. But we want to solve that in a way that you can really attack most objects while making the work cell relocatable on the fly. And then most people without any technical background can reprogram all this, and it works with most commercial arms that we've actually tried. So what is our actual product? What are we actually building? We're building the eyes and the brain for your arm. So our system basically comes as a package with a gaming software, if you a gaming PC, and basically Intel Real sensors. That's it. So we include the vision sensors. Our system comes with pre-installed AI software and a UX that's custom as well, that we basically spend a bunch of R&D on this. And finally, it can power any movable work cell. And all you need to do is stick the camera if you want with double-sided tape, sure. But we recommend screwing it in. You just stick the camera and you connect the Ethernet cable and you're done. You sort of like have AI-powered most robots out there already, and we can retrofit solutions, our work cells as well. So that's what our system looks like. Now let's see it in action, and our system is called Deep Space at the moment. So we can pick complex parts and SKUs, and most of these objects that you're seeing in this video right now have never been seen before. Deformables are okay as well. Whenever it fails, it tries again in a different manner, which hopefully leads to a succeed. And we can scale to thousands of parts and SKUs seamlessly. We do not really need CAD models to work with. As you can see, it failed and then tried again in a different manner. So the other cool thing about our tech is that we don't really need any fixtures. So just this end effector camera-based solutions. So you can move the robotic work cell around very easily. And you can handle deformables, which has been challenging for the community, but I do see some solutions out there as well, which are very cool, by the way. But deformables in general have been interesting and challenging to handle. So we also pick through clutter. I apologize if the screen is lagging, but the idea is to show that we can literally pick up most trash objects that we see. Don't really need any structure to them. None of these objects have been trained on. All of them have been seen for the first time. And as you can see, wires, screwdrivers, pieces of paper, caps, deformables. We have a pick rate of 350, but however, that is limited by the robotic hardware. So what we're building is the software to power any robotic arm. If you have a faster robot, our software speed can scale up with that robot. So that's a key thing to keep in mind. We have only tried on these cheaper robots because that's what we can afford internally at the moment. We can also pick complex parts in dynamically changing conditions, where we do a top-down pick and do a sideways pick as we move. And that lets us sort of handle these different cases where you need to, on the fly, reprogram a shelf pick while you try to do some packing or a pick and place from a bin. So our tech is developed in a more flexible manner, which lets us handle those different use cases, hopefully providing more value than other solutions. And finally, we also let you move and adapt on the fly. So if you have a robot right here, you can move the entire work cell while doing complex pick. Of course, this is not an AMR, but you can imagine this being on an AMR while handling these unseen, complicated items and objects, basically. So this overall shows you how flexible our vision system is. And remember, all of this is enabled, we are independent of the arm. It's enabled only with a vision sensor that we sent you, and we basically send you a PC with all of the software integrated with it. So in a nutshell, we are sort of an operating AI system for a robot. And then we can retrofit cobots that are already out there, or we can help you deploy new work cells. So that depends upon in what stage of automation you are specifically. So how do we fit into the market right now? We feel like we actually add value to a lot of stakeholders. We have systems integrators. We can work with our original OEMs, basically. So in fact, all this is actually happening as we speak. Of course, we work with end user companies and AMRs. We let them address more interesting challenges and projects. So we have aligned interest, which with most, or in fact, if not all of these stakeholders in the market right now. Since we don't really build hardware, we need to partner with hardware companies to provide these sort of like solutions to the market. And so we are currently focusing on 3 different applications for the summer. We will have a productized deployment by end of summer, basically on palletizing, mixed case palletizing, I must say, complex bin picking while being reprogrammable, and machine tending again while being reprogrammable, not needing CAD models for these tasks. So all these tasks enabled only by vision and a computer, a vision system and a computer, to power most cobots and industrial robots, while being reprogrammable by a non-technical person on the fly. And that makes our system quite flexible. That's our aim here. And we are a small team right now. We're 3 people. Myself, my name is Tapan Pal, and I'm the founder CEO, and also serve as a research scientist. We have Ajmal and Vignesh serving as senior software engineer and business development. All of these guys are from Carnegie Mellon and Ross School of Business. So we have a large team of interns and part-time as well to support any kind of project you guys might have. And so overall, we're just looking to see if this sticks, if this is useful. I'm looking for pilot projects to just see whether we can help any other stakeholder in their project. So quickly to recap, we're building the advanced and easy to use operating AI for robots. And if you have to just like remember 3 things for us, we are reprogrammable, we are movable, and we can pick complex unseen parts, cues, and objects. So this is our automate slides. I apologize, the booth number is irrelevant, but please just feel free to reach out to me at contact@voyage.com, and happy to have any questions and chat more with you guys. Thank you so much.
Thank you, Deepan, so much for presentation, and thank you all our partners for making this event possible. It was quite many organizations involved. Thank you very much to Berlin partner, to State of Pennsylvania, to Advanced Robotics of Manufacturing Institute, and of course Fraunhofer Institute for Production System and Design Technology, and Pittsburgh Robotic Network. And I would now invite you for a breakout session where there'll be a chance that you can talk with each other, exchange your contacts, and look for some areas for future collaboration. There'll be 5 breakout rooms. You can feel free to choose the room you want to join. And I hope you will enjoy your networking. Thank you very much for joining us.
Recording dazwischen, alles klar. Genau.